Next question. A conical vessel whose height is 10 meters and the radius of whose base is half that of the height is being filled with a liquid at a uniform rate of 1.5 meter cube per minute. Okay. Find the rate at which the level of the water in the vessel is rising when it is 3 meter below the top of the vessel. Let's draw this first. So there is a conical vessel, okay, whose height is given. Height is 10 meters. Okay, and the radius of the base is half that of the height. Half means this will be 5. Correct. The water is being filled. So this vessel is being filled with the liquid at a uniform rate of 1.5 meter cube per minute. So its volume is changing. So change in volume is given dV by dt 1.5 meter cube per minute. Now find the rate at which the level of the water in the vessel is rising. That is, we have to find the level of the water. So what we have to find? The change in height. Okay. So change in height we have to find. So level of the water, that is dH by dt, we have to find. Okay. Now level of the water in the vessel is rising when it is 3 meter below the top of the vessel. So when our height is 3 meter below the vessel. So here when it is 3 meter, at this point when it reaches, at that point we have to find a h, that is dH by dt. Okay. So this height will be what? 10 minus 3, which is 7. Okay, so we can write, so total height we can write h, that is 10 meter. Total radius, that is the radius of the vessel, is 5 meter. Okay, now the new level at which the water is there, that radius we can take r, small r. Okay, and the new height is 7. You have to find dH by dt. Okay. So volume, how it is given? Volume of the cone is 1 by 3 pi r square h. Okay. Now we are finding change in this height, right? And the volume is changing at 1.5 meter cube per minute. Now look here, we have been given the height, which is 10, and they have given the radius is half that of the height. So radius is half of the height. Okay, so this relation is given. That relation we have to make use of to find this radius. So if I write this radius as r, what will be the height in terms of radius? Because when we are finding the change in volume, okay, that time we want here only one variable, and here we have two variables, right? So we have to convert one of the variable. Obviously we are going to convert r into h because we want dH by dt, correct? So write r in terms of h. So r is h by 2. Okay. Now there is one more question, okay, similar question. In that they have directly given that height is 10 meters and radius is 5 meters. So in that they have not given the relation between the radius and the height. Okay, so that time you have to make use of the triangle which is forming here. Okay, so if I take this as small h and this full, like this it will be. This is our original triangle. Okay, 5, 10, and then we are taking this. It is this becomes R. This is H. So these are similar triangles. And second thing is we can take the theta here. Okay, we can write tan of theta. So tan of theta of the bigger triangle will be what? 5 upon 10. And the smaller triangle will be what? R upon H. So from this you can get half. It is R is H by 2. Okay. So when it is given, like values are given, that time you have to do this. Here no problem. You can use this. Okay. So we'll convert this R into H. So R square we can write H by 2 square. So this is 4. So this is pi by 12 H cube. Okay. So differentiating with respect to t, H square into dH by dt. Okay. So we have dv by dt, which is 1.5. H is 7 square, and we want the value of dH by dt. Okay. So we can write this 1.5 into 4 upon pi into 49. Okay. So this is 60. So 0.6 by 49 pi dH by dt. So we got change in height. That is height. So meter per minute. Okay. Next question. Show that the surface area of a closed cuboid with square base and given volume is minimum when it is a cube. So here we have a cuboid with a square base. Okay. So if you have a square base, then the length and breadth of that cuboid is same, right? See. So for a cuboid, there is length, breadth, and height. Okay. So this length and breadth is same. Say, let's say it is x. What about height? Height I'll take y. Okay. So let length and breadth be x and height be y centimeters. Okay. Or here they have not given any unit. So this is there. Now what they have asked, show that the surface area of a closed cuboid with square base and given volume is minimum when it is a cube. So what is minimum? When the surface area is minimum, not volume. Volume is given. Okay. Volume is fixed. That is volume, using this too we can write length into breadth into height, right? So length into breadth is x into y. So it is x square into y. Okay. So we have to differentiate surface area and not volume. Surface area we have to show minimum and when it is a cube. Okay. So surface area of a cuboid is 2 times length into breadth, breadth into height, height into length. So length into breadth, x into x plus x into y plus y into x. So this is 2 times x square plus 2xy. Okay. So to find this rate of change of surface area, we want only one variable. Okay. So one of the variable you can convert, that is using volume. So y, I can write it as v upon x square. So I can substitute here y. Okay. V is constant. So this becomes v by x. Now we have to differentiate with respect to x because we want value of x. Right? So change in surface area when x is changing. So this becomes 2 x square is 2x. So v by x means this will be x raised to minus 1. So derivative of x raised to minus 1 minus v upon x square. Okay. So this you have to put it equal to 0. Okay. So now you have to find the value of x. So 2 we can take common. It gets multiplied with 0. Then we can write x equal to v by x square. So x cube is v. So vx is cube root of v. Okay. Now differentiating this again. So this will be 2 times 2 minus into minus plus 4 minus 2 into 2 v upon x cube. Okay. So this will be a positive value, right? Greater than 0. So maximum. Sorry, minimum. So when our surface area is minimum, at this point, this is the point of minima. Okay. What will be the height? That is y. You can substitute in this. So y is equal to v upon x square. So v upon, in place of x square, I can write this root of, or we want this y in terms of x, right? So we can write v, we can substitute x cube. So we are getting y is equal to x, right? So all length, breadth and height are equal. And when this happens, that time it is a cube. So this is what we wanted to prove. That is when the our surface area is minimum when it is a cube. Given volume is, the surface area is minimum when it is a cube. Okay.